welcome back to Build Propulsion Lab at whoop, Devoxx UK, coming to you live from London, and my next guest is Simon Ritter. Welcome, Simon.
Thank you very much for having me.
My pleasure, and I get to speak with all the cool people in the conference, which is like the best place to be is here. The second best place is watch those interviews, because then you can watch me having great time with all the great people. So, Simon, Azul, as your shirt implies, is where you work, and we all knew Azul by the JVM that it provides for everybody. I would say one of the leading implementations of OpenJDK out there.
Yep.
So basically, if you go to your SDK man that you should use, if you don't, you really should, but if you do, and do like install Java, this is the Java you get, right?
Exactly.
So we use it all the time, but I know that Azul does much more than that. What else are you up to those days?
Right. So I guess you could say that Azul is a company that's just focused on Java.
Java.
I mean, that is
right.
literally all we do is Java and Java runtimes. And so that sort of falls into two areas. There's what we call platform core, or Zulu. And that's where we have like a straightforward replacement of the Oracle JDK. So it's a build of OpenJDK, taking open source software, we just build it and provide it with commercial support. So it's very much like the Red Hat model of Linux. You know, Linux is an open source project, you can get a Red Hat, get enterprise Linux with support. The other side of the business is what we call Platform Prime. It used to be called Zing, now we're calling it Zing again, just to help people remember. And that's where we take OpenJDK, but rather than thinking, okay, let's just build what's in Hotspot, we thought, how can we improve it internally to give better performance? And that initially took the form of what we call C4, which is the Continuous Concurrent Compacting Collector. So that was the idea of solving garbage collection. And we did that probably like 15 years ago now. Low latency collector, pauseless, much better for low latency type applications. Now we've seen a lot of things that have come in since then. So if you look at OpenJDK now, you've got ZGC, which is based on very much the same algorithm. You've got Shenandoah, which was a different approach, a slightly different approach that was taken by Red Hat initially. So there are different alternatives to how you can do garbage collection. So what we then said was like, okay, how can we improve things further? And we said, right, let's look at JIT compilation, because that's a big part of how we get performance from Java. And we said, right, let's replace the C2 JIT compiler in Hotspot with one that we call Falcon, which is based on another open source project called LLVM. What that allows us to do is generate more heavily optimized code for the same methods, and that results in high performance without making any changes to your code, without recompiling. So it's very much around that sort of thing. And then what we've just introduced more recently is what we call the intelligence cloud. And that's looking at how can we take information from the JVM and use that both for security. So if you want to know, if we take Log4j as an example, when Log4j came out, suddenly everybody had to run around and say, right, we need to update all of our Log4j implementations. A lot of people didn't know where they were using Log4j. So it's like, how do you find that? Now, obviously, we've got static analysis code tools that will give you software bill of materials, that type of thing. But when you're faced with a zero-day vulnerability, absolutely has to be fixed. What you really want to know is, where are those machines that are actually running that library right now?
The only thing that matters is when it runs in production.
Exactly, yes.
Yep.
So what we do is we take the JVM and we know the class loader. So we take the class loader and we recognize which classes are loaded, map that to the libraries. Then if something like Log4j comes up or Log4Shell, you can simply say, tell me all the machines I've got running right now which actually have this library loaded. And then you can address those immediately and then roll out across your estate generally as you have time. There's kind of around that. And then you can invert that and you can do dead code analysis, because if you're not using code, then you can eliminate dead code from your application.
I think this is brilliant, and generally speaking about the intelligence cloud, I see a lot of potential of kind of integrating it with what we do in Gradle, and Elephant is right there, right? The build scans, so we will have the build intelligence, and you have the runtime intelligence, and it's just a lot of intelligence running around.
That's exactly it. It's very complementary to what you guys do, because
exactly.
you're doing the before deployment we're doing the after.
Exactly. Yeah, no, but you wanted actually to talk about something else, and this is Vector API.
Right.
What is that thing? What are we talking about?
Right, so this is what I did my presentation on this morning, was around looking at what's happening in Java. So we're a company that's focused on Java. We like doing all of the good things in Java, and we like to help the community understand more about what's happening as Java is developed. So what I was talking about this morning was an API that came out in JDK 15 initially, and it's still in incubator phase. So we have this idea of preview features and incubator modules in the Java platform now. It has the record for being the longest incubator, so it's in its 7th iteration with JDK 22, and it will be in an 8th iteration in JDK 23, and it will continue to be an incubator module until Valhalla, Project Valhalla gets integrated more into the JDK. But that aside, so the idea behind the Vector API is looking at there are certain operations that you want to be able to do that could take advantage of the way that the processor works in terms of using very wide registers. So vector operations have a very wide register. When you're doing numerically intensive operations where you're adding lots of numbers and processing large arrays, what you can do is you can load up this very wide register with multiple elements from your array, and then apply the same operation to all of those elements in a single clock cycle. So it's doing things truly in parallel, where you've got large arrays of data. Now, if you look at the way that Java works at the moment, if you write a loop and you've got an array and you do some processing on that array, the JIT is pretty smart. And what it will do is it will do auto-vectorization. So it'll look at that and go, okay, I can apply these vector operations to that, everything's great. But there's lots of situations where, especially if you introduce like an if statement, and you say, if element A is even, I want to add that to element B, but only if it's even, then that becomes more complicated. And the JIT compiler typically can't recognize those situations as where you could apply a vector operation. Now, I will say that our JIT does recognize more situations like that. But
so it's almost like you have less need for Vector API.
Precisely.
Yes. Okay.
Precisely. But there are still lots of situations where it's beneficial to be able to code it yourself. So what the Vector API does is essentially say, right, we will represent a vector, this register on the processor in a class, and then you can populate that, and then you can determine exactly what you want to do in terms of addition, subtraction, multiplication, things like that. You can do much more complicated things. So you could do like a reduction operation, where if you're trying to add up all the elements of an array, you can simply say, here's my wide register, here's all my elements, just add those all up and create a single value for that, and do that repeatedly. So there's lots of things that you can do there in terms of improving the efficiency of your code. It does require a bit more sort of manual intervention, so you actually have to write more code to do it, but it gives you greater control over what the JIT compiler is actually going to end up doing.
And that's a blessing and a curse, right? Because Java was about encapsulation, a lot of those inner details or low-level details, so we won't become platform dependent.
Yes.
And all this kind of stuff. And what it sounds to me, that the ability to run those vector operations is very platform dependent.
It is to an extent, but there's quite a nice way that the API is being developed in terms of making it somewhat platform neutral. And the reason I say that is because what you can do is you can either explicitly say, right, I know what the size of the register is on my processor right now, and set it up so you've got like a 256-bit wide register. Or you can simply say, I want to work with whatever's the biggest register that I have on that hardware. And then when you move it from machine to machine, it will simply select the right register, use that. And then if you can write your code in such a way that you say, right, so I know I've got the biggest register, how big is that register, how many elements can I fit in that register, do my loop accordingly. And it's fairly straightforward to do that, so you get cross-platform code. But yes, you're right. I mean, it's one of those situations where you're starting to look at much lower level kind of stuff.
Right.
And if you think about the original goals of Java, so you're very on the ball there with what you said. You know, the original goals of Java was to make it high level language, keep things simple, eliminate that C and C++ explicit pointers and getting
Yeah,
right down
yeah.
into the weeds. But what we've seen is that for a lot of developers, that's really good. But there are some developers who want that lower level of control. Simply the fact that so many people used SunMISC unsafe is a great sort of pointer to the fact that people did want that control
Right.
in certain situations. Most developers never use SunMISC unsafe, but if you're a framework developer, if you're really looking at getting that absolute last percentage of performance out of it, people tended to revert to SunMISC unsafe because it gave them that control. This is more about handing a little bit more control, but in a controlled way.
Exactly. So what we're saying is, if we cannot prevent it, let's at least
yes.
make it, do it properly, and
Exactly.
then you can abstract the real details, but still give people access to this feature, so they will use it in the right way instead of just like doing something that will blow up in most of the scenarios.
Yeah. And we've seen that as well with things like Project Panama.
Yep.
So Project Panama was a replacement for JNI. So now we have a more controlled way of interacting with native code. So we've also got the foreign memory access API that sort of duplicates some of the things we had in SunMISC unsafe. And there will be other things as well after that. But the foreign memory access API allowed us to get that sort of ability to access native memory, but do it in a way that still maintains a level of control, a level of security over it.
Yeah, no, this is cool, and today we learned. Simon, thank you very much.
Great.
It was lightning, and if you are looking for do stuff with vector APIs and white registers, take a look at the vector API, and it's pluggable with as an incubating feature, obviously, and we will see it generally available sometime in the future.
Yes.
Maybe
Yes.
3 versions or so.
And if you want more detail, you can just watch the video of my session this morning.
Here we go. Perfect.
Great.
Simon, thank you very much.
you very
And you all stay tuned. We have more interviews coming up today and tomorrow in Build Propulsion Lab, coming to you live from Devoxx UK. And stay tuned. Thank you.